Go. So, lots of changes if you've been following the keg and the pagan stuff I've been doing over the years. I went to bed last night with my head working on a bunch of problems. I woke up and I just had an idea I had to finish, and I've been working on it straight since God, I don't know, like 8 o'clock this morning. It's somewhat related to work. Don't worry, I'll make up the work time tomorrow and the next day and the next day. But this is really important because it's so key to everything else that I'm doing. Um, so let me try to stick with the highlights. And hell, why don't I actually use my YouTube thing? We're gonna make a directory for this. We'll call it updates on peg. Actually, no. Let's call it something more specific. Then let's say pegn scanner interface and functions. So what I've done. So I mentioned the other day that interface and functions. Did I do that right? Pegn scanner interface and functions. Yeah. I mean, eventually I'll have a tool that do all that. So, okay. So my pegn scanner implementation now conforms to a common pegn.Scanner interface so that other scanners can be implemented by people that conform to it. So the reason that I made an interface, why an interface? So that the library of scanner functions, of scan functions, can be interchangeable with different scanner implementations. And if that is the main reason. And let me show you what I mean by that. So if you go to, so this is all, by the way, this is all, I should probably put it in the thing. I'll put related in here. So here's the pages that we're going to. We're going to http github.com rwxrob pegn pegn-spec, and that's pretty much it. If you go there, you can find everything. It used to be that I had it all over the place, and I used to have there's pegn.dev, but that's kind of it's kind of older, but a little older and out of date. So it's still there. I'm reforming the spec as we go. So we want, okay, so let me show you why. So if we go to the pegn scanner itself here, right? So I mean, what is the end goal? The end goal is for us to be able to parse any kind of language, and we started with BaseML or BasicMD. You'll remember I was BasicMD. I was writing a BasicMD scanner, and here is the so this was all brought about because of this. So I'm just going to put all this precipitated by the basic MD parser that I was right. I mean, a scanner parser AST. So I started writing that last night, and that was all good and everything. But it became clear to me that some of these functions, I'm going to show you one. Some of these functions that I have written them so many times. I swear, I have written, so like, I don't know how many times thank God I didn't post it to you, Tim. I'm not going to force it on you. But I must have written a white space or an end of line parser probably a dozen times in different ways, because I haven't had a standardized way to abstract the scanner stuff in a way that didn't require rewriting a scanner. I mean, I've written probably, including an extremely complicated one. If you go back in my YouTube videos, there's something I was writing. It was called Go compatible pegn expressions, and it was actually Go code that could be passed into symbols that could be passed into another function that would parse it, and then it would do its thing. It was pretty cool. But every time I've written one, and then the most recent iteration of my scanner that I wrote, I just ripped all that crap out. I was like, I want the ultimate in minimal. And thank God I did that, because I actually ended up coming up with, so here's an implementation of the new scanner interface that anybody can write. And all it has is, I mean, some of the stuff is internal, but let me show you the interface first, actually. So let's start with the interface. So the scanner interface, it's in my types. The scanner interface is just a scanner. It's a rune scanner that is aware of the beginning and ending of each rune that it scans, which can be more than 1 byte, right? So people know this. So you can imagine a cursor going, through the screen like this, like with an emoji on there, and sometimes it's a thing. So in fact, the scanner has this idea of a rune cursor. And I fought with myself about whether to call it cursor or not. I did end up keeping a concept of cursor here, but at one point I had it embedded and everything. I don't want to get into it, but so ultimately a scanner it's a bytes buffer, and this is another reason I put this in the peg. So this thing, all of this used to be under rwxrob/scan. I had my own rune scanner in there, but I realized, and I'm going to put this in my conclusions. I realized that my rwxrob scan was actually very peg specific. And what I mean by that is that, so a couple of really important specific assumptions are made by peg. Peg assumes that you have infinite memory, which is, the polar opposite of parsing when you're using anything that you would get out of the Dragon book or in computer science class. And so, that's a huge thing. So if someone comes across my scanner, they're going to say, oh, a scanner, cool. And they might think it's a finite automata, single look ahead kind of scanner. And they're like, what the hell is this thing? It just slurped my whole data source, byte buffer and into memory. That's like an unorthodox thing to do. That's a sacrilege. And that's what peg does. So I realized that the scanner that I have built and been using, the most recent one, which I've used all over the place. I'm using it all over the place. I'm using it in Bonsai and everything. Is actually, in fact, I think I just broke Bonsai by, no, I didn't. Bonsai's got its own scanner. Never mind. Anyway, so I went ahead and implemented it. And I actually also deprecated the other one because I moved the entire scanner into the pegn package, or the pegn module. Because why? Because it's pegn centric. It's pegn centric because a pegn centric scanner, you can't even use it unless you load up a buffer. And that's completely unheard of in other circles. So that was the first major thing. That did mean, however, though, that the other one that I have, which I'm leaving out there because I'm pretty sure I have some dependencies on this scanner, and it's also listed in my Awesome Go list and things. And I have some pretty intense breaking changes that I added to this since version 10 because I changed some of the internal references and everything. And the more I got changing it, the more I see right here it says fulfills pegn scanner face. It actually doesn't do that anymore. I broke that when I was doing the move. And then this is the most accurate thing. So I've moved this entire scanner over to rwxrob pegn, and it is, implemented as under the types. Good night. So it's implemented in the type here. Under types, you can see the scanner is here. It gives you the cursor type and then a scanner type, and you can look it up. And it has a mark and a go to and a scan and a finish. Nothing fancy there, right? And then I included a reference implementation of the scanner that I use for the pegn stuff, and this gets me to where I was going with my basic markdown parser. So how's it going? So here we have pegn. So this is the exact code that was in this other place. That's just been moved and cleaned up, and really cleaned up, and had some other things added to it. For example, the fulfillment of the interface so that it can be replaced with something else at any time. And let me talk to you about why I decided to make it an interface again. I started talking about that, but if you go to, so here's the interface. But as I was working on BasicMD, I started realizing that parsing end of line and end of block and paragraphs and all of these things that are listed in pegn are things that I need to do all the time. In fact, I just added end paragraph, right? These are things that I already need all the time. And I'm like, I've always have intended to write, I've been really kind of hung up on creating a code generator for all that stuff. So you write pegn and you end up with different types of code, right? But to be more practical, I've started realizing all I really need to do is write a scanner function for each of these and then reuse them. And then the ones that aren't in pegn, that are specific to basic markdown or whatever I'm writing, keg or whatever, I can actually write those using exactly the same function signature, and I could even put them in a packages, as a collection of first-class functions, because they all accept the scanner interface. And that is Go interfaces shining the brightest, right? Because that's exactly what you want to do with it. So what does that mean? So I have the scanner implementation here, and I actually chose to make this implementation fast and abstract, so that if somebody chose to use it, they could use the direct references to the byte buffers and stuff like that, so they could bypass the indirection from the interface method calls, which is the reason I didn't do it originally, right? If you look at the highest performance parsers out there, they do not have a lot of functional indirection, right? It's actually one of the biggest complaints I have about the current code generator for pegn that Quint mostly made and I last 2 years ago, is it has a ton of function indirection in it. And that's been something I've been kind of like irrationally hung up on. And I think I finally hit the middle of the road here. So this particular reference implementation, which is a part of pegn, comes with a struct that you can use directly if you want to, which I probably will do, and really quick and dirty, not the quick and dirty stuff. I'll probably will use the abstractions because they're easier to remember, and you can just swap them in and out. I don't need performance, right? But if I'm like really want to make a low level, really intensely often, parsed grammar, then I can go ahead and bypass the use of those things, as long as I don't want to reuse any of the stuff I've already written in pegn, which brought me to think, oh damn, let's say I make here's my workflow. Okay, so I imagine the workflow of making a grammar is something like this, right? So in fact, this is even in a slide at Brian Ford. I was looking at Brian Ford's peg stuff, and he has this in a slide about traditional thing. He used Lex and Yak and blah blah blah, and then the pragmatic approach to doing parsing these days is to write a generic kind of specification and then to write a recursive descent parser. It's the standard way, the practical way to do parsing. And let's say I want to do that, right? So I want to write a grammar, but I want to write it quickly. Now, the quickest way to do it would be to do code generation with, from pegn notation, which is something I still want to do. That's nothing that Brian Ford ever wanted to do. Kind of wanted to get away from it because he realized it was just as fast to just write your own recursive descent functional parser, and then be done with it. You don't have to deal with all the intricacies of code generation not being exactly what you want. You just write it, right? And I'm kind of on board with that idea because it's quite a bit of work to get it to generate just the way you want to, and then which code generation method do you want? Do you want it to be highly efficient? Do you want it to be use functional so it can be easily maintained? Are you going to rerun the generator every time? Is it just giving you the first version? And so at a certain point, you kind of come to the conclusion that probably the fastest way to create a parser is to just write the thing, because then you're gonna be done. You're gonna be done with it, and you're gonna be able to move on to other things. So, and that's kind of where I am. So, also realized fastest way to develop a parser is to write pegn and then function and then scanners. Functions for recursive descent. I mean, it really is. So by the time, you get all the thing, just writing the pegn itself is good. I mean, that kind of gets you thinking about how it's supposed to be implemented. But you're also not wrestling with pegn syntax and stuff in case you get it wrong. Now, you should probably do that, but let's say you don't represent it perfectly in pegn. Who cares? The pegn is just there to help you understand what the parser is going to, how it's going to behave. And then you could, compare it to that, just visually and get to your point. But you can get busy kind of writing your parser. But along those lines, assuming that you're going to write a parser, right? You're going to go ahead and write a parser. What are the obvious building blocks? I mean, code generation is awesome and everything, but what would be the other way to do this if you didn't have code generation? Well, it gets pretty obvious that it would be a standardized library of scan functions that you regularly reuse, right? And as long as you make those export and you make those public, you can pull them in and you can tweak them and make them more efficient, and other people can contribute their own, and you have you end up getting this ecosystem of scanners because it's really, the scanners are really the secret, because if you have a scanner, you can scan it, and if it scans successfully and you get a true at the end of that, I mean, and this is very Haskell-y, right? If at the end, if you get a true after that, you're done. You're on to the next thing. If you don't get a true, then you're guaranteed that the scanner didn't do any advancement because it snapped back. And you're going to see this all over in my implementation of functions, which I'll show you in a second, because that is how you do this. And that is exactly how Brian Ford talks about it in his paper. It's like the difference between the traditional scanner, parser kind of approach, and this is that you can scan ahead as far as you want, and you can keep track of how many matches you have, so you can be very greedy if you want. And let's say, okay, so did I find anything? Yes, I found like 10 of them. And then I keep scanning and like, oh, hey, well, I stopped. So then I like roll back to the last one that was successful. Or if there were none that were successful, I roll back the scanner all the way to the beginning. So this idea of snapping the scanner back and moving it and around a thing, that's a very fundamental part of the PEG architectural approach. Because you have memory. You have memory that you can fly around in, and very quickly, by the way. I mean, moving pointers around in memory is crazy, crazy fast. And you've only had to do the one load. And so, all these things that are doing like single byte loads, in order to do that, you've already had to buffer your data at some point. So you've already had to do the buffering. So the thing that's cool about PEG is it assumes that you're just going to buffer all of that up front. And then you're going to break up your content into manageable chunks that fit within, a reasonable amount of memory that you're going to be parsing. You should put limitations in there and stuff, and that's a part of the grammar design, which is another reason that PEG is a fail, because as wonderful as it is, it does not allow you to put limitations and constraints on this size, which is why I made pegn. So when I say things like, I only want, 2 end of lines here, I can specify 2 end of lines. There's no way in the original PEG specification example to indicate amount, which I just think is crazy given the fact that regular expressions in ABNF have been doing it forever, and EBNF, but PEG decided not to do that. So that's one of the reasons I made pegn, because we clearly want the combination of those things. All right, so let me go back to here. So I went ahead and I implemented a white space function. Right now, I could have probably automated this, but let's look at what it looks like. So if we go into the pegn scan. And you're probably wondering, well, why did you name it scan? Because I wanted it to read well. So let me show you the examples here. So these are Go testable examples, and they are public. You'll remember maybe when I did BasicMD that I kept a bunch of my scanning not public. I was like, because I didn't want people to become dependent on my scanner functions, right? I mean, I'm just making a basic markdown parser. I don't want people to be, including my thing because they want my specific implementations of these. And that's one of the reasons I started thinking, I should probably think more deeply about some of these scan functions that are going to be reusable. And I should probably put them somewhere where they could easily be reused by me and others. And that's what got me to do this. So I've created a convention called sum, which is just a nice happy way. It's like, Go, they like have must and compile and things like that. So I created a convention where you put sum in front. These are all documented in the design considerations on the README page, by the way. But sum means, 0 or more white space, or 1 or more white space. So if I have example sum WS. So, and then the reason I named this subpackage scan is so that we would get these wonderful readable lines here, scan.sum white space, and then pass in the scanner. Now you might be asking, many, many people will tell you that have done scanners that they implement the scanner as a class, which I think is disastrously bad architectural decision, because you cannot do anything with it at all until you expand the class. That is the primary reason that people like Jim Coplane and others hate class-based object-oriented programming. It is so concrete, you can never extend it, not without re-implementing the class or subclassing it. By doing it this way, I can use first-class functions. It's a very functional approach. I can use first-class functions if I want. I can use them from a package, whatever, because the scanner is an argument to the function. And so as long as the scanner fulfills the interface, this is why interfaces are king. This is why interfaces are part of solid, even in modern Java development. If you're not doing this, if you're writing a scanner, writing a class and extending the class with all of the different types and then having to do that every time, you're doing it wrong, in my opinion, because you're never going to be able to extend that in any way that's going to be reusable for anybody. And maybe you don't care about that. I do. I want it to be reusable. I want to create, ultimately, I want to build up, hundreds or more scan functions that can be used with anything whatsoever that implements the scanner interface. And that's why interfaces are so amazing. So I pass the scanner interface. I say scan some WS, and I get a true or false. So this prints out false because the first number is a 1. Now I added a constructor. There's really not constructors in Go, but it's the closest word for it. And this takes an optional argument. Now, constructors are very, very high level, so they don't have to be performant, right? Especially since you're not going to be buffering a lot. So I put an optional parameter or 2 on the constructor. If you pass in a string or a reader or a bytes, a buffer, any of those things, it will work. And it will just slurp all of the thing into memory, and then it will allow the scanner to work on that bytes buffer. And so then we do this. We say, so you can see here, you see it was false, that it's not currently, the scan WS failed here, because why? And you'll notice too that it didn't advance the, oh, it's not supposed to. That actually looks like a mistake. That might be a mistake. Let me check here. Oh, no. Okay, let's do this. Wait, what? Advanced to nothing at all. Output. Example sum WS. I think I might have a problem with this one. Anyway, it's supposed to, I just barely fixed these. That's why I want to make sure that's okay. Sum WS. Is it not working? Let me go try something. Go test. Run sum WS. Huh. Well, let's turn a trace on. Oh, this is cool. I finally got trace working again. So trace, that'll turn trace on. And when we run it, we should be able to see every step of the way. So the first call to scan, got it. That's what the first, that's every time scan gets called, it prints it. So scan the 1 in, and that shows us the from between 0 and 1, and then what's left in the buffer, and there's a space. And then it shows we scanned a a space, and that was between 1 and 2. It could be 1 and 3 depending on the size of the rune, and then the buffer's empty. So that shows it's doing what we wanted to. I just was oh, I know why. It's doing that because this actually did do some scanning, and it did not reset. Actually, that's a mistake. That's a mistake. I need to fix this. Because it didn't scan, it should not have advanced the buffer at all. It should have been. I'm glad I did this. This is a nice catch. And again, this is the bug in the scanner function only, not the scanner itself. Traces internal. Traces is a part of this scanner implementation. It's not part of the forced interface. No, it's not. You don't have to have a scanner in there. That's part of this scanner implementation. So, I don't want to burden people with those kind of details. If they want to do their own, they can, right? But yeah, you could extend that and do what you want with it. So this is actually wrong. This should have been x00, and it should have been 0 to 0, and then it should have been a 1 here. That's what it should be. And then when you do the scan, it should go through, and then it should have been a 1 and a 0 to 1, and then that should have left us with a space, and then it should have been false, and then it should have been true. This one should have probably printed true. Yeah. Something might be wrong with that. Did I? All right. So that's how it should look. So that means there's a problem with my function, my scan function, which is what I was debugging before. But let me show you how to do this. So there might actually be a problem with my mark, and I'm hoping not to. I think there might be something wrong with my mark, which is relatively new. But the point is, I don't know if you saw the functions I was writing yesterday, but these are way, way simpler, right? They just have to scan and check what the runes are and scan again. And the idiom is the same no matter what. You take a bookmark to it at the beginning, and you revert back to the bookmark if you didn't find anything, right? And you leave things as they are. Otherwise, you let the scanner happily proceed along. And it's not like there's a lot of cache in there, so that you'd have problems there. But yeah, I have a problem with this one. I got to come back to it. I can't see it right offhand, but so this is actually this is supposed to scan as much white space as possible. I think the problem is I don't know. We might be getting rune wrong. I don't know. I'll have to go debug this one. But if I wanted to just debug this one too, I could also just do this. I could just do s.trace and turn on the tracing in here while I'm doing this debugging. I can put it there in the test either way. Oh, it's not. That's right. I forgot about that. Man, this is gonna be interesting. Yeah, because you just said, is that in the debug output? Interesting. Yeah, I just realized I'm saying, because I locked down the interface, and I'm going to keep a bunch of stuff out of here I'm not going to be able to do, because this expects a scanner interface, and that means only things that are defined in the scanner interface can turn on. I wonder if we should make trace into part of the interface. We should say you need to implement some form of activating trace. I don't think we should. I think we should leave that in the test stuff, because people can set up their own test cases and then call it that way. I don't know. I thought about it for a second though. This is just as good, right? Having the trace up here, because this is using a specific scanner that fulfills the interface, and therefore it can have extra things in it like trace. The other one doesn't have any knowledge of it at all, and it shouldn't, right? We don't. That's, again, I want to double check that everybody understands this. So we do not want people writing, pegn or any scanners functions that are going to be doing fancy things that are not defined by the interface. Because if you do, then they won't work interchangeably with other scanners. And that's not ideal, right? We want to be able to have people write very highly optimized scanners however they want. I mean, all of them obviously are going to have the downside of having to call out to functions to do their thing, but it's not too bad. But that way people can supplement the scanner that I have made or make their own or something like that, and they can share all of these scan functions with each other. And we can make libraries of scan functions that do different amazing things. So it's basically like creating a library of regular expressions. And if you look at the pegn stuff that I've been doing, you can see that we've got a lot of functions to write. So over the next year or two, I'll be implementing individual scan functions for the different types of stuff that is included here and in our tokens. And yes, we're gonna have functions for things that are strictly static, and the reason is that is to keep everything functional, because we need to be able to pass the scanner to it, right? If we didn't do that, we would have different kinds of dependencies. We would have dependencies on the pegn like implementation to some degree, I think. And so that, I mean, it's not that much extra. Before I was like calling out to a function just to parse the references to the other functions. So it's not going to be any less performant than any of the other stuff. And that's really premature optimization. If somebody really, really, really wants that level of performance, they probably should write their own scanner and maybe just use some of the scan functions without it and not bid. So, but I will be writing, like, I'll probably be auto generating a bunch of Go code to stand for each one of these scan functions, and then they'll all be under scan dot whatever. So I'll be able to just, on any project, I'll just be able to do import rwxrob /pegn /scan, and I can get any and all of these that I want. And it's not that big actually, because it's just text parsing, right? It seems big because it's a lot of code for us to write, but most of it's going to get inlined, and the size of the package isn't going to be too big. And then we get kind of like this regular expression engine that's on steroids, because now we can just write our own recursive descent parsers as easily, or if not easier, than we could write regex, complex regex expressions. And that to me is kind of the holy grail, because that's what I want to do. I have like 4 or 5 grammars that I want to finish that I'm kind of waiting on, and that's where it leaves us. All right, so I need to come back and fix this white space one. Let's go back and look at one that maybe works better. So here we have, I put the pegn line up here. So end of the line is, we scan the found Boolean stuff. We don't really need that. I could have just done a return right here and called it a day and not gone all the way down here. And the reason I didn't do that initially is because I wanted to think about how this code could be auto-generated. But now that I'm looking at it, I am totally okay doing that. So we can just do return true there. Here we can just do return true. Yeah, and if we make it down this far, that means we didn't find it, and we need to do that. So that this is not hungry. If you're using something that's hungry, yeah, you might have a different problem, right? Because you need to if you're having something that's like hungry and greedy, you need to like count all of the finds, and you'll see that kind of thing happening over time. Oopsie, did I refer to found in here? Return false. So I mean, that's a simplification we can do. I want these to be highly optimized. Another reason, by the way, that I think code generation is probably the wrong way to go, and the more I keep coming back to this, the more I think that handcrafting a recursive descent parser from a huge library of existing scanners, scan functions, is a better idea because of this problem that you just saw. The optimization I just made is the kind of thing that would take an extreme amount of intelligence in the code to be able to write it in a code generator. Whereas if I'm just writing the parser, I can do tricks and stuff inside of my functional parser to make it really, really optimized for this particular scenario, and I can do things that couldn't be done if I were to genericize the generation of this code from the syntax. So what I'm saying, and I'm going to put this in here, is that I'm kind of souring on the idea of code generation. So I'm souring on the idea of pegn to code generation, because it's removing, it prevents, it precludes optimizations that only a person could do. And people definitely do this. And if you're gonna, I mean, at the end of the day, we're writing a compiler when we do that kind of thing. And there are people that have spent their entire lives dedicated to compiler optimizations. Well, one of the reasons that having a human write a scan function is better is because depending on the language they're writing it for, they might already know how the compiler is going to inline that code. So having some genericized rendering of the code may not be able to take advantage of those things. And premature optimization, yes, right? We want to avoid premature optimization, but at the same time, we don't want to be forced into doing things that we could do because we know about them later on. We could come back to the code and we could actually say, well, okay, let's optimize this one because this is my pegn function for parsing, white space. The most important thing that I'm ever going to write is going to be used by millions of people or whatever. And I should really, really optimize that one function. And then everybody can spend their time optimizing the functions that we have for parsing those specific things. And we can maintain a community library of this rather than having everybody write the best, their own white space parser, right? So we can actually have a collective community of contributions that from people who know about parsing, or really, amazing Go specialists who have know how to optimize code based on what they know about inlining. So yeah, no more code generation. Just a lot of pre-generated libraries that are immediately importable, and then we can just write, and with if statements and switch statements, and you can write your own thing really quickly. And I think that's really going to be the new normal. Useful form overlooks, yeah. And so yeah, I think that's kind of how I am with this. That is why you're developing anything. Yeah. I think that the code generation thing, I mean, this doesn't mean we're not going to do some code generation, right? But we're going to statefully code generate like all of the functions for the 200 or so Unicode classes, which by the way already have functions. Yeah. So for those kind of things, that's exactly how Go does it, by the way. Go takes that document and it generates the Go code straight up from the Unicode specification document. And it has a whole library of true or false kind of things, right? But it's not a scanner. And so the only thing we're going to have to do in the Go one is basically the same idea, but we're going to say, okay, is this thing a thing? And then we'll make a sum variation as well, so that it'll be like one or more of those things, right? And all that code will get auto-generated. So we'll have a pretty big library of scanners that'll be developed that you can then make your recursive descent parsers from. And maybe we can get somebody else to actually think it's a good idea besides me. Optimizing a lot first is that you can find you don't need the functions you're optimizing. No, that's right. That's what I'm saying. So a lot of them, yeah, you could combine the two things together or something, right? Yeah. So I think I'm kind of happy with this, where we're going with this now. Now I still have this bug here, my white space bug, but the other one is fine. Let's try to run that one. Let's do run. What was it? The end of line, I think, right? Oops. Let's turn scanning on end of line so you can see it. End line. Man, there's lots of end lines. So should we use the carriage feed one? Actually, let's just turn it on for the whole scanner. Yeah, scanner has a trace for the whole entire package if you want to turn tracing on everything. Yeah. Trace equals, I'm probably going to have to do an init here. Trace equals 1. Yeah, it's going to say you need to put that in init. All right, fine. This is just for now. There's other testing ways to do this, but I'll just do that for now. So we could go test. So actually, this is going to show every single parse that we did. I'm so happy with this. So when you turn the trace on, when you turn it on this way, it'll actually give you like the full thing. So here it read the first carriage return, and then a line return, and then another line return. So that was that one that we did, and there's another one. So these are all the different ones. There's no other printing statements going on in there, but you can kind of watch what's getting parsed as you go, and check on it. You can go look at that and see if you like it. But yeah, I mean, it's working. That part will pass. I just got that white space one I have to figure out. So I think that's enough for this video. I just wanted to show where I was. Some of the, I mean, the end paragraph turns out to be end block. So remember yesterday I was doing basic markdown and I was like, we need to delineate our blocks. Well, what do we have? We have any number of spaces, and then a greedy include of white space and line returns, and that's what this is. So I had to rewrite it and say, do I have the end of the data? Do I have an end of line and then the end of the data? Or do I have two end of lines, which are, the greedy thing, and then the white space splat and, peg repeat operators are greedy by default. So that says grab as much white space as you can. As far as I know, I might have that wrong, but grab as much white space as you can, and then make sure you have this at the end, right? Now, it may be that I have to, if I were to put this up here in the front, then it would be non-greedy. So it would get, it would get the first one. So the first match of, I had that happening before. I had the first match of a line of double line returns, and it got the first one. So that's how you do non-greedy, is you put that stuff up in front here. But you have to kind of look at the peg syntax to get that. That's from Brian Ford. That's not from me. But I still have to go look it up every once in a while. But once you get it, it's much easier than regular expressions. It has positive, negative look ahead and all that kind of thing, which regular expressions, depending on which engine you're using, don't really do well. Not to mention, the ability to capture things. So, and I use the block here and go to, which I actually prefer to for loops because they just are so much cleaner. Because you just know you're going to go up to the top again, and the thing I like about it's much easier. I mean, it's much harder to write an infinite loop with a labeled block than it is with an infinite forever loop, which is just for, and I used to do them that way. Because I mean, you definitely can, but you have to explicitly create an infinite loop that keeps going to the top again, right? So it's kind of like a do while. And you see this all the time in parsers. This is in Go. It's in Go's compiler for the language that GoTo is a very real, solid thing to use for compilers and for parsers and scanners. And it saves you from any kind of functional recursion, which is the devil when it comes to performance in parsers, because you hit indirection function loops, functional recursion loops, and stuff like that. Some languages it's the preferred way to do it, but most of the languages are not. Most of them want you to stay within there and kind of figure out a way to short circuit and go back up to the top. And it's more performant that way too. So this one has to have the whole notion of a found Boolean in it, because even if I find one, I still want to look for more. I still keep wanting to look for more until I'm greedily get the last one, right? And before I added a notion of a found loop in that, I wasn't getting everything. And so what it does is it keeps getting stuff until it hits something that is not valid. And it's like, okay, I finally ran out, but did I ever find anything along the way? It's like, oh yeah, okay, well, what was the last one that I did find? And then, it can tell you that thing. And that's what the go-to is. This is actually wrong. I'm just realizing I have some problems with this. Yeah, it's funny because now that it's cleaner and I've got to spend my whole day fixing up all of this syntax, I can see that this is probably wrong, because this is going to, this is oh no, I'm sorry. No, I'm sorry. This is only if it's not found. Yeah, this is only if it's not found. Okay, so scanners do not advance. So the rule this is a kind of a hard thing to come up with when you're trying to figure out how to make your parsers and functions and stuff. But the easiest rule is for a scanner is if it scans, it returns true and it advances the scanner. If it doesn't, to the next thing, right to the beginning of the next thing. It doesn't scan that thing, it puts it right to the beginning of it. If it doesn't, if it doesn't scan anything, it needs to leave the scanner exactly how it was before it was called. And in order to accomplish that, you need to take a bookmark so that you can snap back to it, right? And I put go to here. I could probably do snap, but that would people would think of snapshotting or whatever. Go to is the one I'm going to use there. So that actually sets it to the cursor, and the cursor is three things. It's the byte index in the by buffer array of the of the first item in the rune, the first byte of the rune. It is the rune itself, a copy of the rune. That's what we get when we go get .rune. And it is it's also the end of the rune. So the byte pointing to the byte array to the beginning of the next thing, which is like maybe 1 or 2 or 3 things away, and that's where we got this. See, so we get like a 3 to 4. If I were to scan like a tomato emoji, and I don't know a way to go back to mark point. If it found the end of paragraph, it considers it advanced and no more. Go back to mark the point. You don't need to mark the point because the scan automatically advanced it. Yeah, because any of the scans that failed, I'm pretty sure. I mean, I have to go back. But there are cases. Yeah, I read that. I have that book. I wrote that years ago, a couple of years ago. I have the PDF somewhere. Yeah, I actually bought it. There's that one. There's 2 or 3 Go scanners in the Go code base. And then there's a website that has write your own scanner and Go. Those are the 3 main things that I'd recommend if you want to start doing this kind of fun stuff. But yeah, they're pretty cool. And I'm obsessed with parsing. I'm not very good at it, but I'm obsessed with it. So anyway, mostly I'm obsessed with language, and so grammars are a part of language, and that's why I like it so much. This is something I don't understand. What I want to do is I want to be able to specify my bonsai command lines from a pegn. Wouldn't that be cool? There is a writing compilers. Oh, really? Yeah. I have to go look at that one. So yeah, I mean, the compiler is the next step, right? It's like bringing it all together and doing something with the thing you get out of it. And we don't have any notions of AST going on yet. That is coming. I already have all the data structures for that developed that I'm going to use for my AST. But yeah, so, you got to have push and pop for ASTs. It's like crazy. Yeah, I mean, the hardest part with the AST, and we're going to get into this, is how to throw away elements of the tree that you can't just pop back. You can't just pop back to the latest bookmark when you're doing parsing, because you have all this data that you parse that you can't throw away, and it's very complicated. You can't throw it away because you don't know how much of it to throw away, and that's going to be a big piece of this that might I still have other things to do. This isn't my main thing. So, but I am interested in this. So far, the test case on this is so good, so important that you have lots of test cases on this. I'm pretty sure this one is good. But I don't know. We'll go take a look at it later. Here's the thing. I don't want to have to keep revising all of my parsers. I'm going to go back and open up my old pegn dev. I wrote an entire recursive descent parser for the pegn language itself. Viable. And so that's going to be something that we're going to come up with later. But so I don't know how that's going to end up going down. Because I want to be able to pull out some of that stuff from here and just reuse it, because I've already got all the algorithms there and I can just reuse those algorithms. So that's pretty much it for YouTube. So if you want to stay tuned and watch stuff about the pegn and keg stuff, I'm probably not going to be working on much of this. Hopefully not the rest of this week. I've got a ton of work to catch up on that I'll be doing like for the rest of tonight and or tomorrow morning early, um, and we'll be I'm going to be doing a lot of that stuff. But this is sort of related to stuff we want to do at work in terms of like documentation, validation. That's where it came from originally, and that's if you want to stay tuned, we'll do some more of that. I am going to implement BasicMD as a grammar, and I'm going to be using this, and we should get pretty high performance on it actually. We should have performance that rivals Goldmark, which because it doesn't have as much to do. So we should have performance that rivals Goldmark, which is pretty much the go-to standard for markdown parsing in Go right now. And we'll be able to compare and do some benchmarks on that a little bit later. So have fun parsing and come on by sometime. Talk to you later.